Hey, welcome back, everybody. I'm here with Julie Lerman, who's going to do an amazing talk for us on EF Core, fulfilling the bucket list. And I'm very excited. Julie, I'm sure this is packed with demos. I'll let you go in and get started.
Demo. Thanks, Bill. Yeah. Oh, that coding. So, hi, I'm in Vermont. Sorry, I'm not in Vilnius. Sorry for, a million reasons. But, here we go. So, EF Core 6 is released. Last time I did this talk, I was still using, the pre-release version. So it's fun to actually use the release versions. And I call this talk working on the bucket list because it feels like that's what the team is doing now, like all the things that they've been wanting to get to and we've been asking for a long time. So that's with the bucket lists. There's so many new things. Obviously, I'm not going to show you every single thing. So I'm gonna show you some of the things that are interesting to me, and I think have broad interest across .NET users. So just to make sure everybody knows where we're at with releases. So obviously, well, not so obviously, EF Core 5 came out with .NET 5 a year ago. EF Core 6 just came out with .NET 6, and it's important to know EF Core 6 is long-term support. EF Core 5 was not. So what's going to happen next is a year from now, .NET 7 is scheduled for release. So I think it's a good assumption to think that EF Core 7 is probably going to come along with that. However, it's also important to understand that because it's not long-term support, EF Core 5 support ends May of this year, so like in about 6 months. And then EF Core 3.1 has been long-term support. That support's going to end in 2022. So, moving to EF Core 6 is good for all kinds of reasons, but also the fact that this is the long-term support version that's going to carry you for a whole bunch of years. Good to know. There's a link down at the bottom where you can find the roadmap for all that information. So I think the most exciting thing about EF Core 6 is the impact, the very positive impact the team has had on query performance. So they really focused on that a lot. And what they did was a lot of people look at Dapper, another ORM, very lightweight ORM, works very differently than any framework, but it's a .NET ORM. And people like to compare the two. So, it's an ecosystem. It's not like there's a competition between the two. And in fact, there's a lot of scenarios where you want to use them in a hybrid way, use Dapper for some things and EF Core. But what they did was they said, let's do what we can to try to at least get our performance as good as Dapper's. So they did a lot of things to work on that. And what they used in order to really benchmark how the performance improvements are was they focused on the Tech Empower Fortunes benchmark. So that's a industry standard, and it's focused on using a full stack of something and comparing full stacks. How many operations per second, particular like queries per second, can be performed. So they used that. A lot of the improvement. So like overall with the full, with that benchmark, because it is full stack that they're looking at, they've got a 70% faster improvement in the speed using .NET 6 and ASP.NET Core 6 and EF Core 6. And I think that's with PostgreSQL, by the way. But of that, EF Core 6 itself, they, with their numbers, they say that that's now about 31% faster in executing queries. And, more links down there on the bottom of the screen so you can really see all the details where I'm pulling this out from. So looking at the Tech Empower Fortunes test and seeing where that 70% comes from, I just pulled out some basic numbers here for you. So where they started was comparing was with EF Core 5, not EF5, sorry about that, EF Core 5 and .NET 5. So, and comparing EF Core to Dapper. So you can see EF Core was only doing about 148,000 queries per second, where Dapper was, 230,000. It was a lot. So the first thing they did actually was they modified their test. So they aligned with the requirements of the Tech Empower's Fortune's benchmarks. And just in doing that, they were able to get a lot closer to Dapper. So that's still with EF Core 5 and .NET 5. So that gave them, a pretty nice improvement right there. Then they just said, okay, now we're going to switch it to .NET 6. So we're still in the ASP.NET Core and EF Core 5, everything. And as we know, .NET 6 is a lot faster than .NET 5. So that gave some more improvement. Then they finally got into EF Core, so they could really compare apples to apples. And so just tweaking the APIs inside of EF Core, and again, this EF Core 6, not EF 6, and using it with .NET 6, there's that 31% improvement. So interestingly, if you were to look at the Tech Empower's benchmarks right now, they show benchmark round 20, which was from February of this year, which was still using EF Core 5. If you want to see where the benchmarks are, they actually have previews and they update them like constantly, maybe multiple times a day, not just Microsoft, but all the different stacks that are on the benchmarks. So there's a link on the screen there, and you'll have this, it's a long link. You'll have this deck so you can get that, so that you can actually see the previews, so you can actually see the closer data. So what did they do inside of the EF Core API to get all of this speed improvement in the queries? So you might be familiar with DB context pooling. And what they did in EF Core 6 was they also added pooling in for DB connections and DB commands and DB data readers, and a lot more along that pipeline is going to be pooled and make it faster. So that just happens on its own. You can with the DB context pooling, you still have to explicitly say you want to pool, but we've been able to do that for quite a while now. Another thing they did that was a really big deal was they looked at how, like during when a query is trying to be executed, they're constantly looking to see if, if you wanted to add interceptors, are you doing logging? They're constantly looking for that information. And so what they did was they reduced the amount of times, like instead of like 1,000 times per second, right? Maybe they're doing it 10 times per second. So they're still doing it frequently, checking for that logging and interception stuff if you need to, pull it up and tap into it. But they, they reduce the amount of time, and also it's just a little bit delayed and you wouldn't even notice it. So that made a really big difference. So most of the changes are internal and you don't have to even do anything to benefit from them. But there's another one that they made, which is that you can opt out of thread safety checks. So it's really important to make sure that your applications are thread safe, but you can do all of that work before you're in production, right? And make sure everything's thread safe. Then when you're ready to go to production, you can opt out and save, there's another 7%. So Shiro Jansky wrote about all these improvements. There's a blog post, and also the full details on GitHub you can see are in this issue that I've linked. Again, if you're furiously screenshotting or writing that down, there's, you can get the deck afterwards. Really important thing to understand about the query performance in EF Core 6 is that their focus was on non-tracking queries. Okay, so if you're doing tracking queries are the default, right, with EF Core and Entity Framework 6 also. Tracking queries are the default, but non-tracking queries are really important. Like we use them when we're creating web apps, there's a lot of reasons to use non-tracking queries, and they're a lot more common than non-tracking queries. So they focused all their efforts, most of their efforts are impacting non-tracking queries, but they do anticipate now taking what they've learned and applying it to tracking queries for EF Core 7, normally tracked queries for EF Core 7. So, so if you're doing your own little tests, you might, go, why isn't this working? And that could very well be. So I built a test. Actually, I built it with the help of Shai Rojansky again to make sure that I was putting in all the right bells and whistles and taking advantage of things properly. But this is not lab tested, not something that could be put on Tech and Power's fortune. I'll show you a little bit of what my little application does, what it looks like. But just on my own computer, doing a test where I'm just grabbing 1,000 rows and I'm using pooling in EF Core 5 on .NET 6. So I, didn't want to have my tests also be reflecting the change in .NET 5 to .NET 6 performance. So this is just really trying to focus on EF Core and EF Core 5 and EF Core 6. So in my test to retrieve and materialize 1,000 rows, it was 3,000 milliseconds. I'm like, oh gosh, the US, yeah, I think that's the representation of milliseconds, of course. And that, but in EF Core 6, it was 1,400. So that's not quite their 30%, but if I did this over and over again, I would maybe be able to have even cooler numbers. But I am using benchmark.net. So benchmark.net is a great tool for making sure that you're doing lots of iterations and warm-ups, and it gets rid of the outliers and does all kinds of things. And just to also point out, the query performance isn't really that noticeable with one row, right? So with 1,000 rows, it's pretty impressive. So just so you can see a little bit of what I'm doing, and all this stuff is on my GitHub repository. So what I'm doing, and I have the same exact code, except for one difference, where I'm using EF Core 5 and using EF Core 6. So I'm just looking at the EF Core 6 one right now. So I am using pooling DB context factory. So it's taking advantage of all the pooling, and that, the DB context factory pooling existed already in EF Core 5. So the EF Core 5 version is still taking advantage of that. I'm disabling query tracking. And for the EF Core 6 one, I am opting out of the thread safety. So there, that's the one difference between the two different branches for EF Core 5 and EF Core 6. And then I'm just spinning up the pooling factory, and I've got a predefined query that grabs 1,000 rows, and it's not complicated data, right? So it's pretty clean. And then a query that creates one row, grabs one row. So it's really just that simple, and you can take a look at that demo if you want. So you can see that, that's my results. It's really fun. I think it's really fun to do benchmarking, but I do love benchmark.net. So startup performance, that is another big feature that, not just query performance, but starting up performance. I don't know if you might remember that in Entity Framework 6, we had a way to, not Entity Framework Core 6, EF6, we had a way to pre-compile models. So there's a new way of pre-compiling models in EF Core 6. Is very different than the way it worked before. Arthur Vickers built a really cool demo that has gobs of, really, really complex model, right? To speed. So the idea is, that first time NA framework has to figure out what your model is at your application runtime. It has to do a lot of work. It has to read the entities, it has to read the context, any extra mappings. It just has to figure everything out. There's a lot to do. And the more complicated your model is, the more time that takes. And, I'm always like, well, why do you have big models? Like nobody should have big models, but that's just not the reality. A lot of people have big models and that startup time is killer in application. So his demo has all of that like crazy model with so much going on in it. And in his demo, which I actually have, you can download it. He has it on GitHub. Link is there. I downloaded it. I ran it myself. Oh, I didn't rerun it with, I ran it. I haven't run it since the RC1, but basically, that was pretty close to what we have today anyway. So creating the model on the fly without taking advantage of pre-compiled models. The startup time was about 1.8 seconds. And with the pre-compiled models, his crazy big, huge model was down to 157 milliseconds for the app to be ready to roll, because the EF Core didn't have to do that much work, quite as much work to figure out what the model is. So that's a lot faster. So how do you actually make compiled models happen? There's a new command, a new migrations command called optimize. That's it. We run the optimize command, and there's a PowerShell version of it, and it creates a folder with a whole bunch of optimized files that describe the model. So Entity Framework Core doesn't have to go through all that work that it was doing. You're gonna pre-create all that stuff. So now when EF Core has to figure out what the model is, it just looks at those files, and it's a lot cleaner. And then you need to tell EF Core to use that optimized model. So there's a use model method now on the options builder. So I will show you a little bit of that. So I've got, when you go to GitHub and grab, when you go to GitHub and grab my demos, they're all in different branches, just so you know. And I have been checking the suppress this warning all morning long, and it still won't stop suppressing. And then I just need to give C# a kick so the compiler is okay. So I have my demo is really simplistic. So the compiler benefit's not going to be nearly as impressive, but it would be too hard to look at this with Arthur's demo. So I want you to see this the first time with my demo. So I just have a person class and an address class, and they have a relationship, pretty simple stuff. Maybe I need to build this .NET build, because my warning went away and it came back. And the code's perfectly fine. I hate that warning. And context is as simple as it can be. So how we create this is, as I said, .NET EFDB context optimize. Live coding, how many typos can you make? Apparently none, yay. So now we have this compiled models folder, and inside of it, we've got 4 files. So there's going to be one entity type file for each of the entities in your model. So I've got one for person, and here it describes every bit of mapping information and configuration information, even that which is inferred, right? The conventional stuff. It's all just explicit here. So Entity Framework Core doesn't have to think, right? I love that. Don't make me think. So it's everything it needs to know. The table name and everything is described in here. The address entity type, it's the same, and it also has information about the relationship between address and person. So here's foreign keys and information like that. Then for the model itself, there's 2 files. There's one that is really just very vanilla. You don't even see anything about person and address in here. So this is about initializing the model. And the model builder is what has the information about the types in the model. So, but notice this is about the address entity type, not my address. So it's going to use this information. Then the last bit that has to happen here is I need to go to, as I showed in the slide, I have to use model. And then which model do I use? I have to tell it to use the people context model. Model instance, which is going to trigger the model builder. And, oh, come on. Just need that. Okay, that goes away. So now what I'm going to do is I'm just going to run, my program does just about nothing, but it does trigger the, it does instantiate the people context and just do a little thing with it. So I'm just going to randomly put a breakpoint inside of one of the entity types and a breakpoint inside of, I'll do it in the model builder. Oh, it's already there. And then I will run this. And just so you can see, it's inside of my my new generated stuff. So there it is inside of the model builder or the model, and there it is inside of my person entity type. So, with my little bitty model, you're not going to see, benchmarks going, oh my gosh, it's 10 or 11 times faster, but it's a little easier to see what it created. So that's what I have to show you for the compiled models. And I just need to clean things up before I move from one. This is that, it's really handy to have all the demos in different branches, but there's a couple of weird things related to that also. So next thing I want to show you. So about performance, right? I'm trying to be really fast here too. Although this is not a performance, we're moving to something else. So DevOps friendly migrations, right? Everybody wants to have something that says DevOps in it. So this is amazing. We can now bundle our migrations, right? Migrations work really, really well when you're debugging and doing everything on your machine. But what happens when you need to say, you've got a web app and you've got changes in your migrations and you want to deploy those changes to the production app and the production database? It's always been tricky. This is one thing, people, like the first idea, let's just put in an app startup. There's all kinds of, and for those of you who aren't from Lithuania, that's just no in Lithuanian. I think that's what Google Translate told me, at least. How are we doing? Anyway, so that's actually really problematic because when you get into a scenario where, let's say you've got your app, you need to scale out. You've got different Docker containers. Imagine that you have to, the app is starting up and you're, deploying some more containers and the app is starting up in a couple of containers. Every one of those containers is going to try to run the migration that's in app startup, right? And you could have all kinds of terrible side effects. So that's really something you don't want to do. Another option, which is something I've actually done some conference talks on this. It's a really cool way to go, especially if you're using Docker, is you can generate SQL scripts and then feed them to your favorite tool for running SQL on databases. So I actually use FlyawayDB in a container and it's really cool. So that's another way to do it. But now we have another way that something people have been wanting for a while is have it built into Entity Framework Core. So EF Core 6 has a way to bundle up the migrations and then execute them. And it's very aware of if item potency in your migrations also. So that's really important. I actually tested that. I can demo that for you as I'm looking at the clock going, oh, what am I going to show? What am I not going to show? So again, just a command line command or migrations command. And it's .NET EF migrations bundle or bundle-migration. And we have an output option. So you can, it's going to put it into a file called efBundle, or if you're on Windows, efBundle.exe. So you can change the name of that if you want. You can also make it self-contained. So efBundle by itself will just run. You can, again, put it in a container, right? We're talking DevOps. in a container that has .NET in it. If .NET's there, efBundle can run there. But also you can create a self-contained bundle. It'll be a much bigger file. And also the force option is because by default, it creates the efBundle file. So if you just want to create a new file with the same name, you just force it and it'll overrun it. Also good to know is when you run efBundle itself, you can add a connection string if you want to do that. So my clock is hiding behind my microphones. So I'm like, what time is it? All right. So I'm going to, for the most part, I have a feeling that if I just told you it works, I don't have to show you any code. But that would be absolutely no fun, right? Because we're all programmers. So here's bundles. Yes, Visual Studio Code. Thank you very much for that important information. So I already have this, by the way, there's no compiled models in here. That's just detritus from moving from branch to branch, detritus, some people say. So I have a migration here already. I still have the very simple model. I've just got, the person and address, and not much going on in here in the context, except for the sake of showing this off to you, I have created a shadow property. So there's a shadow property that just tosses a timestamp into the person entity, and therefore the person table in the database. And then I am just, I have an event handler. We got a bunch of events in EF Core 5, by the way. So I'm just using an event handler to update the shadow properties whenever some data is being inserted or updated and a person is being updated in the database. So have to do that once in a while. Okay, so what I'm going to do here is go to the command line and .NET ef migrations bundle. Dun, 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 dun. Oh, come on, Visual Studio Code or OmniSharp or whoever's doing that. Okay, so here is the efBundle executable, and I'm just going to run it. So this, what it essentially does is takes all that information and calls DB context or database update, right? It just updates the database. So if the database doesn't exist yet, it will create the database for me. So I have to do efBundle, and there's the database. I'm going to look at it in this SQLite Explorer extension and show there's the migration has been applied. Okay. And I have just a little program. All it does is insert one person. So I'm just going to do .NET run. And I'm doing this part because I want you to see the item potency. Okay, so now I'm going to show this table, the person table, and you can see I just added it, and there's the timestamp on it. So now I'm going to go back to person. Now I'm going to change my schema, okay, which is going to mean performing a migration. So I'm going to go into my person and add a middle name. That means I need to create a new migration. .NET ef migrations add middle. I can't believe I'm actually hitting the right keys on the keyboard. I am overly caffeinated right now. Okay, so I got a new migration. There's the middle migration. Now I'm going to create a new bundle, a brand new one. I'm going to overwrite the old one. Why type when you don't have to? I forgot to say force. Dash force. It's in there. I spent so much time trying to solve that stupid problem. Okay, so now wow, that's really obnoxious. So I'm going to run the bundle again. So notice it only applied the middle migration. So there's the idempotency, right? So I wish I could see inside of efBundle because in there somewhere it's saying, you know, if this, because my migration file is not idempotent, right? But it's creating idempotent T-SQL. Now I'm going to go ahead and run my little app again, because, you know, these are the things that I asked about it. Like, you know, what's going to happen if I create another one? So I'm going to go and look at the people table again. And notice now I have both of the rows. So the one I inserted the first time around and the second time around. So, you know, running the migration, running the bundle did not mess up my production database. Okay, moving on. If I can get to PowerPoint. So here's another one, temporal table support. This is a really big deal, but please don't laugh. I've been programming and interacting with databases for over 30 years. I had no idea. I'd never heard of it before. They're like, oh, we support this now. It's a really important feature for a lot of people. I'm like, what is it? So I feel that I need to assume that if in my 30 years of programming, I didn't know what it was, you know, there might be a few people who also don't know. So I want to just explain that first. It is a SQL, it's something in SQL databases. So it's not specific to SQL Server, although it is it a standard? It's not implemented the same across the board for different SQL databases. This is what it looks like in SQL Server. A temporal table is marked as system version. This is a screenshot from SQL Server Management Studio, right? So, and it also shows up, like if you're looking at Azure Data Explorer at your SQL table, it will indicate that it's a temporal table, but it's not called temporal table, it's called system version, because the system, in other words, the database is going to keep track of the versioning. You don't have to deal with that in your code. Next is look at that people history table. So it's like this internal table that's part of the temporal table. And it's, you know, it's a sibling of all the columns, right? So there's all the columns. Notice that I have these two tracking columns. They're really important, period end and period start. They can be named whatever you want them to be. So inside the people history table, it's just the same exact schema as the people table, including the period end and period start. What happens is, again, you don't have to, those fields need to be there, the columns, the period end and period start, but the database takes care of them. So when you do an insert, the database will say, okay, it got inserted. The start date is this moment in time, and the end date is like, you know, some date that Doctor Who can travel to, but will never be alive, like 9999 or something like that. Then if you make a change to that, SQL Server will update, well, first it'll take that data and push it into the people history table, but it'll change the end. So it knew the start time. Now the end time is not the Doctor Who time, it's just the moment in time that you made the change. And then it creates the new data with, you know, the start is this moment in time and end is 9999. So the database takes care of all of that. So how is EF Core 6? So first of all, I just want to say that is actually pretty cool, right? But it's also important to know for those of you who do or think about event sourcing, it's not the same at all as event sourcing, because what we're doing is we're tracking the actual state. We're time stamping or keeping track of the actual state, not the events that are changing state. So EF Core 6 now has a new mapping called isTemporal. That's it. That's basically all you need to do to make it happen, to either have, you know, let's say Entity Framework is generating the schema for you. So it will take care of that. So when you do a migration, there's new migration API stuff that will get into your migration file. So there's all these annotations, but additionally, the migration will create a period start and period end column for you as part of that migration. You can control the name of that, right? It doesn't have to be period start, period end. And also for SQL Server, that SQL Server requires that to be date time too. So, using SQL Server provider, it will take care of that, no problem. And then when you execute the migration and create SQL, it'll create the SQL that your database needs to create a temporal table. So you can see here, this is for SQL Server, and it's created date time 2 columns, generated always, and it under this as row end, as row start, that's the flag for SQL Server to know that these are the start and end dates for the temporal table feature. System versioning. So in SQL Server, we're seeing that name a lot, that term a lot. So that's the term, right? We don't call it's not called temporal tables in there. So what else does EF Core give us? Link queries. There's 5 of them, as of, all, between, from, to, and contained in. So you can either just say, get me data, and it'll just get the current data, or you can actually leverage these different temporal queries and methods and get data for a specific time. Oh, I have a really cool demo. I think I'm not going to go through all of it, even though it's like super cool. What I'll do instead is I'll just show you a little bit of this code. The problem is, the problem is I want to show you everything that changed in all of Entity Framework. And, I can't do it. It makes me so sad. No, the problem is this is 45 minutes instead of 8 hours. Then I could do everything I wanted. Temporal table support. Okay, let's get rid of this. Get rid of this. So this is really just, looking at what I showed you in slides. It's really fun to play with this just in SQL Server itself. So you'll find in that branch of the repository, there's a file that has these in there. So you can, will generate some data, then you can look at it, then you can update it, and then do a temporal query. So in T-SQL, this is what one particular temporal query looks like, right? So just doing the query, and this is the key, right? For system time as of. So it's going to look through the current data and through the history table to find the right version of that file when it returns that data. So, I have to build. Come on. Oh, I hate all of that. Okay. I'm doing a little keyboard command that I learned about this. I added into Visual Studio Code that gives OmniSharp a kick in the shins, because OmniSharp does not like when you go around to one branch and another. So I just made a keyboard mapping for that. So this is really just, I'm not going to run it, but all this is going to do is going to seed some data. Then I manually change some of the data and then run a query. So I just want you to see what the link version of the query looks like, which is right here. So, I'm doing something that's the same as the as of query in that T-SQL. I've got a date, which I've predefined. And then I'm just using the temporal as of method and passing in that audit date. And so, it's really as simple as that. So you don't even need to know how it all works, right? But why do anything if you don't understand how it works? So all of the different link methods work in that way. And this would bring back, this is going to go and look in the history table. And again, Entity Framework is just going to be smart enough to create the right T-SQL, and then SQL Server does the actual work. And it also does, the SQL Server also does the work when it comes to creating those timestamps. Oh, what more can I show you? Oh, I stopped PowerPoint. Okay. All right, here's something near and dear to my heart. We now have bulk conventions and converters. So this, you might be familiar with that. If you want to have a different convention, say, the default for SQL Server provider is every string becomes like an nvarchar 4000. Maybe you want a different default, right? Before, in order to code that, bulk config. Yeah, Bill, I think Q&A is going to just be collect all the questions, and I'm going to write a big blog post answering them, because this is a lot more fun, right? In order to do that, like say, oh, I want them to be 100 instead of 4,000, you would have to write this code, which is completely not discoverable, right? You're gonna Google until you figure out how to do that. That's a pain in the butt. So now what we can do is just say, this is saying, look through the model and find all the strings, and let's set the SQL column type to varchar 1000. That's what that code's doing. So for EF Core 6, all we have to do is use this have column type. Now, how does this work? It's because we have this new overridable method, configure conventions. So that's now part of DB context. So all that goes inside of configure conventions. And that gives us the model configuration builder. So, it's just like options builder and, these paradigms that we're already pretty familiar with, like on model creating and on configuring. So that's for changing kind of that configuration. Also, we have the same kind of thing for conversions. So for type conversions, instead of having to explicitly say, say I have an address type enum and I have it in 7 different classes, I would have to say normally has conversion for that property in each and every class. Now I can say have conversion. And you can also do that if you have custom conversions. So that's that. My 45 minutes is almost up, isn't it, Bill? Oh, your picture went away. You lost your beard. I'm looking at a new picture of you. So there's that. And a couple of the things I want to be sure you're aware of is there's been some really great work in the Cosmos DB provider, but it's also good to consider the work that not only all the work they already did for EF Core 3, but the new stuff they've added into EF Core 6 is that they're really planning now for enabling document DB providers. So these kinds of features that they're adding, we're going to see for other providers for document databases will be able to take advantage of them. Really important is EF Core will understand, oh, it's a document database. Well, duh, of course, ownership is owns one, what we think of as owns one and owns many, which we have to explicitly configure for a relational database because it really is doing something. It's tricking the relational database, right, in order to do what we want. But we don't have to trick a document database. So it's like, yeah, we'll just embed it. And you don't have to explicitly say owns one or owns many. It'll think, oh, document database. Well, that's the natural way to do it. And it won't just be for complex types. If you have even a regular related type like addresses, do you see addresses has an ID? So you wouldn't normally do that with owns one or owns many. So if you've got a related type that even if it has an ID, if there's no DB set for it, then it will say, oh, that's embedded also. So that's really super cool. There's more logging details for the document database, and this is wonderful. again, something document databases can do, SQL, relational can't. It will be able to store collections and dictionaries of primitives, store them naturally, which is really cool. For those of you who have been waiting for more parity for GroupBy, I actually had to learn a lot about how to use GroupBy in order to figure out, in order to build these demos and understand it. So I don't really use it a lot. So I just want you to know to look for these improvements, some really nice things in GroupBy that will actually enable you to bring back full entities instead of just aggregates. So that's really important. And it brings, this was a highly requested feature that you could get top N when you're doing GroupBy. So that's in there. Another thing to be aware of, those of you who are doing ASP.NET Core apps and are worried about minimal API and being able to, specify DB context, things like that, with the dependency injection, that it's supported. They know how to deal with that. So you can absolutely do that work. Another one, people have been, the EF team has gone back and forth about how to support this over so many different iterations. So now you can control, there's still a default, but you can have better control over the order of columns when NA Framework is actually generating the database for you. That is it. All kinds of links for you here. My contact information, you'll have access to the PowerPoint. I think I am 1 minute over. Sorry, everybody. And thank you. And I wish there was another way to say, okay, I'll hang out with you later, but we'll figure something out. But all this stuff is on GitHub. Bill is going to send me all the questions he's been monitoring in the chat, and I will build a blog post doing my best to answer all those questions. Thank you so much. Have a great rest of the conference. And for those of you in Vilnius, miss you. Bye.
Thanks so much, Julie.